Boats have been around for centuries. They are important to our lives whether we know it or not. We use boats for defense, recreation, trade, and much more. Now, imagine a world without boats. How would we trade? You could say airplanes, but airplanes are expensive and they have a weight limit. How intimidating would the U.S. military be without boats? Would the Navy consist of rafts? Just as we depend on boats, boats depend on physics in order to work. So what is physics anyways? To you, physics is just another chapter in your textbook. To scientists, physics is the branch of science that deals with matter, motion, and energy. Think of physics as a tree. It has many branches. Physics is vital to motion, and without it, many things would have remained undiscovered. For example, scientists would have never learned how to make ships without studying buoyancy, a part of physics. And just like a puzzle, a ship has many parts that helps it go, and physics is just a small piece that contributes to its motion. A ship has many different parts that will help it move, such as sails, an anchor, spars, just to name a few. Here's a diagram for the back parts of a traditional ship with sails. Here's a diagram for the middle of a ship. Here's a diagram for the front parts of a ship. And lastly, here's a diagram of the parts located throughout the ship. As you can see, some boats have many parts while some boats are fairly simple, like the picture shown. There are many different types of boats as well. Though boats may look and function differently from each other, they all have one thing in common: buoyancy. So what does buoyancy mean anyways? Buoyancy is the ability to float. Boats and ships are, or at least should, be able to float. Basically, a ship or boat floats by displacing water. The amount of water displaced by the ship weighs more than the ship. For example, a boat that weighs 60 pounds displaces 80 pounds worth of water, so it floats. A rock that weighs 1 pound displaces 1/4 pounds of water, so it sinks. Also, a ship is usually hollow, and things that sink like rocks are dense. Thanks to buoyancy, a ship floats. But how does a ship move forward? There are many ways to describe how a boat moves since there are many different types of ships. But today, let's say we're in a rowboat or canoe. In this particular case, the rowboat moves due to Newton's third law. So what is Newton's third law? You may have heard of Isaac Newton, the person who discovered gravity. Newton's third law means that for every force, there is an equal or opposite reaction. Take this balloon, for example. When you release the air in the balloon, the air rushes out, pushing back. The balloon itself moves forward. In a rowboat, the oars push the water back and the boat accelerates or moves forward. When the wind blows against the sails of a sailboat, the boat moves forward. This is an example of an equal reaction. A boat also moves by cutting through water. We could explain this movement using the hydrodynamic effect. So what is the hydrodynamic effect? Hydro means water, dynamic means force, and effect means result. So when you put the words together, hydrodynamic effect means the result of water's force. The boat pushes water aside as it moves through water. So in conclusion, physics and boats go hand in hand. Without physics, there wouldn't be boats.